Okay, so today I'm going to show you the Chapter 10 R assignment. The assignment that we're working with today is ANOVA, well, the chapter. So the first task is that we have to run the by function to print the statistic descriptives for each group. And I did that here. So this is the command that I ran, and this is the statistic descriptives for each group. So then we're asked to run, not run, but set the categorical variable group to factor. And this is my command here. So essentially what that command did was set the group labels the group levels, so group 1, group 2, group 3, to being labeled as punish, reward, and indifferent respectively. I did this because this was how it was presented in the problem, so I just ran with it. Then we had to conduct a Levene's test. The purpose of a Levene's test is to test the homogeneity of variances. And our ANOVA, one of the assumptions of the ANOVA is homogeneity of variances, a variance of the data. So the command that I ran was this one, and I got this. This value right here is what we use to determine if it is significant. Well, yeah, basically. So this value is bigger than 0.05. This means that our variances are not different from one another, so they're the same, which is good because that's what we want. If it wasn't, then that's a whole nother can of worms we'd have to deal with. But I'm happy with what we got, because that means we're moving on with our assumptions. So the next thing we're asked to do is to carry out a one-way ANOVA and calculate the effect size. So I did that, set it as a model, as a linear model, ran this command in summary, and I got this here. So essentially what this is telling us, this is giving us our sum of squares for the residual and for the group, the mean squares for the group and residuals, and then our F value and our value for statistical significance. So F tells us the overall effect on a group. Well, it tells us the overall effect of the group on what we're measuring. So our F value here is 21.01, and this value right here tells us if our F has a significant, if this has a significant effect. So we see the little stars by it, and it's also way less than 0.05. So that means we do have a significant effect, which is good. So there was a significant effect of teaching styles on exam scores, which is kind of cool to know. And then it's asking us to calculate the effect size. So I got the effect size from just square rooting this number here. And you can see the command. And this is the number. So it had a relatively moderate to strong, a strong effect. So that's good. It's kind of bomb to know. So for the next task that we have to do, it's kind of similar, except that we had one added thing here to do. So we're asked to run the by function to print the statistics descriptives for the groups. So, doggone, I gotta load it. I'm doing. Okay, so everything is attached. So we're going to run our buy function. And so here we have all the statistics descriptors for each group. And then it also asks us to set the categorical variable hero to be a factor. So I did that. Here, gonna run it. So what this did, it set all the different groups that we have in hero and labeled them specifically as Spider-Man, Superman, Hulk, and Teenage Mutant Ninja Turtle. So 1 is Spider-Man, 2 is Superman, 3 is Hulk, and 4 is Teenage Mutant Ninja Turtle. Jesus, I can't talk today. Okay, so then we have to print an error bar graph for this data set. So I'm going to do that. Oh, I ran a Levine's test too. Oh well. That's less things that I have to do. So essentially what an error bar tells you, it gives us a general idea of how precise the measurement is. So it gives us the variability of the data. So what we see here, looking at Superman, so the severity of injuries with kids in the Superman costume is significantly different from the other data sets. Well, not other data sets, but these 3 here. So that's kind of cool and upsetting to know. Yeah. So the next thing that we have to do, that we're asked to do, is to do a Levine's test in order to test the homogeneity of variances. And as you knew from the last couple minutes ago, I did that. So that value right there is telling us, that right here, it's telling us that our variances are not equal to one another. Oh, they are. Scratch those words a couple seconds ago. So our data is not different from each other. So our assumptions have been met. So that means we can carry on without any extra work. Yay! So we just ran the one-way ANOVA. That's what we have to run. Yep, sticking to it. So we ran our one-way ANOVA, and our F tells us the overall effect of what we have. Well, the overall effect of costumes on the severity of injuries. So here we have 8.3. We have, for our F value, is 8.317. So we do have a significant effect because this is way below 0.05. So yeah. I was also informed that we didn't necessarily have to do the post hoc test, but I'm gonna run it anyway. I'm gonna do it anyway to show y'all I know I can do it. So it asks us to conduct multiple comparisons to test the hypothesis that different costumes are associated with more severe injuries. So the way to do that, the reason why we're doing it is because when we just run a one-way ANOVA, it doesn't essentially tell us which group does what. It just tells us that there is a significant effect. So we're going to do the post hoc test to determine which group gives the most effect, essentially. So I'm going to run the Bonferroni test. Okay. So what you see here in regards to Superman, you notice that Superman gives, well, this is significant. I don't know why I was beating around the bush with that one. It's significant, so that means there's a significant effect from the Superman costume as compared to the Hulk costume. Same thing with Teenage Mutant Ninja Turtles. That's kind of cool to. That's kind of cool and sad to learn, but damn. All right. So we're also asked to run, well, to calculate the effect size. So we'll do that. Summary. Square root. So essentially, I just square rooted this right here, and I got this value. And that's it, folks.